So we were discussing functions. For example, if we have f of x, x square minus x square minus 4 divided by x minus 2, or g of x minus 4 divided by x minus 2, and the x minus 4 is absolute value. So these like functions we have tried before in our previous class. Yeah, so we will replace, to evaluate this function at the value of 2, then we will replace each x value by 2. So the first function will become like this, that f of x equal to 2 square means x square, the x replaced by 2 square minus 4, and the denominator x will replace by 2, so 2 minus 2. So 2 square is also equal to 4, and 4 minus 4 equal to 0, and 2 minus 2 equal to 0. So you see the function final value is infinity, because 0 divided by 0 is infinity. Okay. In the same way, if you replace the other, if we use the second function, then replace x value by 2. So 2 minus 4 absolute value will be 2, and the denominator is again x minus 2. So x is 2. So 2 minus 2 will be 0. So this function is also infinity. So if the functions are like this, that we cannot find its final value, meaning to say, like the final value become infinity if we replace each x by 2. Okay, then at 2 it become infinity. But what about if we use other value than 2, but very close value to 2? Not the point. This point is very important, because later on we are coming to this concept. Okay, so the point is that at 2 that the function is infinity, but if we select any other value near to 2, for example, you see 1.9 is almost near to 2, or 1.999, okay, that will be much more closer to 2, or maybe even 1 or 1.5 or 1.8, meaning to say any other value, even negative value also. If you put negative 1.9 square, so the square will make it again positive, so then we can at least get some value, but not infinity. So the point is that the final conclusion is that at 2 the function become undefined, but any near value to 2 the function has some value. So this concept is called the x approaching to 2. The 2 is the x value, but when we select any other value which is near, very near to 2, then we get some value. This is called approaching value. So for example, you see, as the value of x approaches to 2 from either side means that if you are using positive value 1.9, 1.8, 1.99, anyone, or if you are using negative value, negative 1.5, 1.9, negative 1.8, and so on, like this. So if you use from any side of the 2 any other value, but not 2, then the value of y equal to f of x, meaning to say that the value of x is almost near to 4. If you see here, it is 3.5. If you get if you put the x value 1.999, then it will be much more closer to 4. So we can say like this, that if we get any value other than 2, but near value to 2, then the function overall value is near to 4. So this concept mathematically, we can say that the limit of x, it is called limit, when not the point, when the value of x is not 2 but approaching to 2. Approaching means that it is very near to 2. If you look at the graph, you see this is 1, okay, this is 1, and this is 2, but the arrow, this one, is just near to 2 but not 2. Okay, so if it is near to 2, then you see the function value is almost here. Okay, and it is 1, 2, 3, and it's almost near to to 4. So this concept is called that when the value of x is approaching 2, then the limit of f of x approaches to 4, and symbolically or mathematically we write this like this, that limit of f of x approaching to 2, you see the x arrow 2 means the x is near to 2, okay, then the function value will be equal to 4. Any confusion? Hello guys. The graph is also showing the same concept, and mathematically we can represent like this. Okay, now we are going towards the definition of limit of a function, or definition of a limit. Okay, so how to define? I have divided the definition into several pieces for you to that you could easily understand. Let's try to define that. Let f of x is the function, that if the function f of x be a function defined at all values, you note the point, all values in open interval containing a. What does this mean? Open interval means that it may be any value and containing a also. A is also included there. Okay, a is also in the set. So an open interval may be a series of value like 1, 1.1, 1.10, 1.15, 1.2 and so on. There is actually millions of possible values in this open interval. Okay, and this open interval is a set of many possible values, and this set also contain the a. Okay, and previously the a value was 2. Okay, so now with the possible exception of a itself, meaning to say that in these all open interval values are okay, but exception of a itself, meaning to say except the value of a. So if let's suppose the value of a in the previous function case is 2, okay, then the function is infinity. So therefore except a, all other values we can apply. Then you see exception of a means a will be excluded from this open interval. Then let L be a real number. L again may be any real number, and any real number is a very big set of number. If you don't remember what is real number, actually the integer numbers 1, 2, 3, 4, 5, the decimal numbers 0.1 to 1.2 and so on, all the decimal numbers, all the quotient number like 1 over 2, 3 over 5 and so on. Meaning to say real number is that much bigger set of number that all the other number types are actually included in real number. So meaning to say L can be any real number. Okay, so at that case what will be the definition? If all values of the function f of x approaches the real number L as the value of x but not equal to a. Note the point, any other value than a of x approaches the number a. So meaning to say that if we use in the function any real number, okay, from the open interval, then we will get some other number as the value of function, and the value of function we represent by L. Okay, so in that case then we say that the limit of f of x as x approaches a, meaning to say x is near to a, and you just think like the a equal to 2, okay, that x approaches to a, then the function f of x will be equal to L, and L represent any real number. Okay, in our previous example it was 3.5. Okay, so the conclusion is that as x get closer to a, then the f of x, the value of x, get closer and stay closer to L. and L is any other number. So in a very short words, it means that if we use any real number as a value of x, but except the a, in our previous case the a should be 2, except the a any other value if we apply in the function, then we will get some value, some answer, and that value is in the real number set. Okay, so the value will be near to L or very close to L and stay near to L. So this again, in a very simple words, that if we use any other number other than 2, then the value of the function will be some real number but not infinity. We will get some value. So this is this is called the limit of a function. So meaning to say, when a function results into infinity, or when the function become undefined, then what we do, the mathematician introduce a new concept that, okay, if at that particular value the function becomes undefined, why not we should try a little bit other value than that number, but that the other number is very, very close to that number. So meaning to say, the limit of x is not undefined, but the f of x is undefined. Okay.
It's in my own word. We pick the like you say just now, the x should be 2, but if we put 2, it will be the infinite. So we choose the number that close to 2. So we will get the answer, not infinite. I don't know how to say it. Sorry,
Yeah,
sir.
you are right. Exactly. Okay, good. Very good. Anyone else? Anyone else? Okay. So, and then mathematically we will represent this concept, limit of a function, like this, that limit when x approaches to 2, x approaches to 2 means that x is not actually equal to 2, but it is near to 2. Then at that time the function value f of x will be equal to L, and L be any number from a real number. And as I told you, real number is a very bigger set. Okay, from real number you can all the integer numbers, the float number, double numbers, the decimal numbers, and actually the quotient, the fractions, like all the values which is in the form of numerator and denominator. So meaning to say, all possible values are actually in the set of a real number. So when the x value is near to 2, then the f a function overall will result in some number, and that number mathematically we just represent by L. Okay, and L may be any number from a real number set. Okay, it's the same definition and the same example like our previous slide, that if the function is equal to f of x equal to x square minus 4 divided by x minus 2. So if here we replace the x by 2, then you see, just look at the denominator. 2 minus 2 will be 0, and anything divided by 0 will be infinity. But the same function, in the same function, if we don't use the value of x equal to 2, but if we use a very near value to 2, like for example 1.9, 1.995, 1.96, 1.99, and so on, then we will get any other value, and that value is almost close to 4 in this case, and this 4 we represent here in by the letter L. Okay, and it is the same definition. Okay, the same concept we can represent by table also, like evaluating a table value using any limit of a function. The function can be any type, like for example limit of when x approaches to 2 and the function is sine of x sine x divided by x. And I hope you already know that the sine and cos and tangent, these are different theta values. Theta represent angles. Mostly in our geometry and in the trigonometry, we are using different shapes like triangle, rectangular, square, and all these shapes have different angles. So when we are trying to measure the value of angles, we are mostly using sine theta, cos theta, and tangent theta and cosine theta and so on. Okay, so I hope you remember something that, so limit of x approaches to 2, sine of x divided by x. Now the values of x is given in the table first column, and the output of the function sine x divided by x, okay, is this one in the second column. So for example, if we replace the x value by negative 0.1, then the sine x divided by x equal to 0.998 and so on. So we can say that it's very close to 1. In the same way, you see, negative 0.01, its value is also very close to 1. And similarly, negative 0.001, you see, the value is quite closer, the input value are closer to 1, then the output value is also very closing to 1. For example, if you see here, as the value as the value reaches to 0, meaning to say, you see, from 0, negative 0.1, and then more smaller, negative 0.01, and more smaller, negative 0.001, and more smaller, negative 0.0001. So as the input value getting smaller and smaller and smaller, the output is going closer and closer to 1. And actually it is from both sides of the 0. So we can say that actually this number is now very close to 0. But you know, in a number line, 0 is in the middle, and on one side is negative number and on the other sides are positive number. So you see, from the negative side, if you are coming closer to the 0, the output is getting closer to 1. And now from the other side, from the positive side, if are you coming closer to the 0, so you see 0.01 is closer to 0, then output is 0.9983, so closer to 1. And more smaller than this, 0.01 is again, you see, more closer to 1 as compared to the first value. And more smaller value means it's more closer to 0. You see, the answer is getting more closer to 1, and more closer to 0, more closer to 1. You can observe the number of 99 here, and the number of 99 here, and the number of 99 here. So this number is much more closer to 1. So we can say that as the value of 0, sorry, I think I have made a mistake. This should be 0. Yeah, this is not 2. This one is correct. That when the value of x getting closer to 0, then the function value sine x over x is getting closer to 1. So this is also the same limit of a function concept, but we are representing through a table. There is a tendency in the input and output that as the input goes near to the given value, here the given value is 0. Okay, that as the input value getting closer to 0, the output is getting closer to 1. And another point that it is, you see, 0 has both two sides. Something can come close to 0 from this side also. Okay, from this side also can come closer, and from this side also something can come closer to 0. And actually both concepts are clear, correct, that if you come closer to 0 from negative side, still okay, or if you come closer to 0 from positive side, still okay. And it is clear from these values. And actually these values are correct in calculator. if you use calculator and apply these values like sine of negative 0.1, you will get some value, and then divided by negative 0.1, okay, you will get this number. Do you want to try by calculator? In simple words, if we try to define a limit of a function is like this, that limit of some function over x, and the x will approaching to some given value. It may be 2, it may be 0, it may be any other value. So the limit of that function means that when the x getting closer, it is called approaching. When the x is approaching to the given value, let's suppose 0 in this case, then the output is always getting closer to a real number, and in this case the real number is 1. And this is clear from this example, that from the negative side, when the input goes near getting closer to 0, the output is getting closer to 1, and from positive side also, when the input is getting closer to 0, the output is getting closer to 1. Okay, now the same thing is represented by function by graph also. So you know, we have different ways to represent a function, and we are applying different concepts on a function, like evaluating a function at a given value, and then finding the limit of a function at some given value, and then showing the limit of a function by a tabular values, and finally we can show the same concept through a graph also. So if you look at this graph, it is very clear that you see from this side, you see as you go away from 0, you see the more away from 0 until you reach, you see this number here, the graph x equal to 3. So when we go away and reaches to 3, on positive side, you see the graph comes down until 0. And from negative side also, when we are closing to 0, yeah, and maybe we are at near to 3, or negative 0 negative 3 point something, and here also, then you see the graph comes down until become 0. But when we reach to 1, closer to 0, here you see at 0, when the x value is 0, the y value is 1. Okay, so meaning to say, as we go near to 0 here, we are getting the value 1, but when we go near to 3 point something positive value or negative 3 point some value, then the graph become 0. Okay, and if you want to ignore this side of a graph, okay, just focus on this, that as we go near to 0, we are getting the y value near to 1. So the point is that we can represent limit of a function by graph also. These values are input values, okay, and these values are output values. So as we near to 4, okay, the output is here, and this output is 0.25. okay, so the more closer to 4, the more closer you will be to this output, which is 0.25. And if you apply the same values in a calculator also, that x square root minus 2 divided by x minus 4, okay, then and if you put the value of x, any of this, meaning to say, you see any value near to 4, 3.9, 3.99, 3.999, and so on, then we will get this output. Okay, so you see this value also. So this one we are coming to from the left side towards 4, that will be 3.9, 3.99, and so on. And if you come from the right side of 4, like this, from the right side, then meaning to say, let's suppose here, then this will be 4.3 something. Okay, if you start here, this will be, let's suppose, 4.2. If more near, then will be 4.1. And if you put 4.1 or 4.01 or 4.2, all these value, the more closer value to 4 will be the more closer value to 0.5. Is it make sense or no?
Yes, I can see.
Okay, very good. If anyone else, let's continue. Now, you see, in the same way, if you want to try like this, that evaluate each of the following limits. Limit when x approaches to 2, that then f of x will be what? Okay, limit. So this one, f of x is simple x, so it will be 2. So any near value to 2, the output will be, it's like a identity function, that whatever is the limit, okay, it will give you the same output. So the near input to the function, the output will be also near to x. The second function, limit x approaches to 2 equal to 5. So here the f of x is a constant value, meaning to say, in this case, if you give any such value which is near to 2, the output will be 5. So any value like 1.8, 1.9, 1.99 near to 2, the output will be 5 by any value. So it means it's like a constant type of a function. So the limit of x. Now this one, evaluate limit x approaches 0 when the x is near to 0, then sine 1 over x will be what? Sine 1 over x. So do you want to try? Do you know how to evaluate?
Just put the number, right, sir?
Yeah, just put the number. You see, sine of, you will calculate. I think let me calculate first one value.
Okay, sir.
Wait, like this one. Okay, so make it totally 0. So it is x approaching, the x value is negative 0.1. You guys should help me later on. Negative 0.1. So sine of negative 0.1, and x value is negative 0.1. Negative 0.1 or 0.01. Yeah, 0.1. Okay, 0.1. So I just replace the x value negative 0.1. The rest is the function, the given function, sine of 1 over x. Okay, and the x is negative 0.1. Okay, so in this case, the answer should be, you see, 0.5444 something. So the answer is near to 0.5. But if I change the negative, the other value, 0.001, negative 0.001, then let's see again. What's the value? Let's clear this. So sine of 1 over negative 0.0001. Okay, the answer is 0.3 some value. So the point is here that we are just trying to understand how to evaluate any limit of a function by all these different values. The function given is, when x approaches to 0, you see negative 0.1, negative 0.01, 0.001. You see, as you go down, the value is getting closer and closer to 0, and actually there will be some pattern in the output value also. So do any one of you have calculator, and can you help me to put the values here? Or you don't know how to calculate?
I think I can't, sir, because when I calculate, I got different answer than you.
Really?
Yes, I think I can use calculator well.
Okay, let me use. Okay, so we are discussing the concept of limit of a function, and now we are trying that the limit exists or doesn't exist. Limit of some function exists or not exist. So how we will decide that the limit of some function exists? So if we apply input like this and we get output in a consistent way, like you see, the input is also consistent. The consistent means that it getting closer and closer to 0 according to this definition. Okay, so if we getting closer to 0, the output is getting closer to 1. So there is a consistent output, and there is a pattern between input and output. So when this situation exists, then we can say that the limit of a function exists. But if there is this type of pattern, that you see, there is consistencies, almost consistency in the input, but in the output there is no consistency, totally in different quad. If you look at the coordinate plane, okay, so the 1 will be here, but the -1 will be here or here. Okay, so it's jumping around too much, so the output is not consistent. So if the output is not consistent, then we can say that the limit of a function does not exist. In this case, I think there is no tendency in both cases. Here also the same answer, and if you go more closer, the same answer, and if you go more closer, the same answer, and more closer, the same answer. Okay, one pattern is this one, and another pattern, you see, there is a tendency of getting closer to some value in the input. You see, 2 over pi, 2 over 3 pi, 2 over 5 pi. So if you see, we are getting closer to some input value, but the output is actually fluctuating. It is not according to one consistent or getting closer tendency. Okay, so in that case we can say that the limit of a function doesn't exist. Okay, limit of a function doesn't exist. Okay, next one is like this. There are different laws of limit. Okay, in mathematics, every time when we get some concept, then actually we apply different laws, like sum law, difference law, multiplication law, division law, quotient law. So these are common laws, and the same laws we can apply on a limit concept also. For example, if you see here, that if we have a function like this, that limit where x approaches to a, and you see inside the limit, there are two functions, f of x plus g of x. So the two functions are added first, and then the limit is applied on the overall result. This is equal to the individual limit of f of x plus the individual limit of g of x. This rule is called sum law. Okay, and it is this function will result, let's suppose, in L, and this function will result in M. Then we can say that the overall output is equal to L plus M. And the same is similarly the difference law, that limit of f of x minus g of x, meaning to say the f of x value and the g of x value will subtract from each other first, like the g of x will be minus from the f of x first, and whatever value we get, then the limit will apply on that. Meaning to say the limit is applied on the result of the minus operation first. Then it will be equal to limit of f of x individually, limit f of x, if we will get some value. I am representing, let's suppose, v1, we get v1, and then minus, we will calculate limit of g of x, then we will get some another value, v2, let's suppose. Okay, then v1 minus v2 we can write as a L minus M. This is called difference law. Okay, so we are discussing the laws of limit. So this one is constant multiple, meaning to say some constant is actually multiply to the limit of a function. So you see limit x approaches to a, and then the c is the constant. Constant is multiplied to the function. So this is equal to the constant. Now come out, first find the limit of the function and whatever value you get, and then multiply the constant. So in both cases, actually it is equal. If you calculate like this or if you calculate like this, the result will be constant multiply the value of the function. And product law, when two functions are multiplied to each other, okay, like f of x multiplied g of x, okay, f of x multiplied g of x, first find the product, the multiplication value, and then apply the limit, you will get some value. So that value will be equal to, if you find out the limit of f of x first and limit of f of g of x first, okay, and whatever value you get and then multiply the values again, in both cases the value will be same. So it means it obey the product law. And the quotient law is called is the division, like f of x divided by g of x. So whatever value you get, limit of that. It is also equal to, if you find the limit of f of x first and then limit of g of x, and then divide the value of the limit of f of x by limit of g of x, you will get this value. So it means it obey the limit, also obey the quotient law. Okay, so next one is power law. So you see f of x, limit f of x, so and then power of that, you will first find out limit of f of x. Let's suppose just assume that, let's suppose limit of f of x is 3, okay, and then this 3 has a power, any power, let's suppose 2, okay. This will be equal to, not this one. Let's suppose the x is 3, 3 square, and we will get, let's suppose 9, and then limit of that, okay. That will be equal to like this also, that if you find the limit of f of x first and whatever value you get, the power of that. So it is equal to L raised to the power of n. So it means it obey, limit also obey the power law. Okay, and root law, root is any root, okay. This is why it is n. Mostly we are using square root when nothing is written, it is called square root, and the value of square root is 1/2, okay. And if it is not square root, then the n is written here, it is called nth root. So nth root of f of x, we will get some value, and then apply limit on that. It will be equal to, if we find limit of a function and whatever value we get, and then we get nth root of that, it will be equal to this. So it means that limit also obey the root laws. Okay, so let's go ahead. Power law we got, root law we got. Okay, so in this way, you see, we can just in one simple example we can apply like this, that limit when x approaches to -3, then 4 of x and plus 2. So here is, you see, the sum law, like 4 of x plus 2, this is sum. So we can do like this, limit of 4 of x plus limit of 2, you see, like this, limit 4x and plus limit 2. And you see here again, if you just recall, this is actually the 4x. So the 4 is a constant and x is a variable, so it is like a constant law, okay. So we can, in that case, we can apply that law, and we can put the constant outside sorry, and limit of x plus limit of 2 when x approaches to -3. So now you see, if we replace the limit of x approaches to 3, the -3 value, and multiplied by 4 plus 2, so whatever value is here, its value is 2, because it is a constant function. Okay, so 4 multiply 3 minus 3, it is -12 plus 2. So -12 plus 2 equal to -10. So in this way we can evaluate these type of limits, applying the laws of limit. Okay, this one is the quotient. You see the difference law, the multiplication law, and the quotient law are all together. Like 2x minus 3x plus 1. You see 2x square minus 3x. This is the difference law. And 3x plus 1. This is the sum law. Divided by is the quotient law. And the x square is the power law, and plus 4 is again the sum law. So in this way we can calculate all these values like 2x square, 3x plus 1, okay, and divided by x square plus 3. This will be equal to the limit of the numerator and limit of denominator if we apply the quotient law, okay. And then take the constant out, like 2 and 3 out, and limit of x square then, and limit of x, and then limit of 1 divided by x square separately plus limit of 4. So in the denominator is the sum law, okay. So this will be equal to limit of this minus, like limit of x square, limit of x, and limit of 1, and divided by limit of x cube and limit of 4. So if you replace all the values accordingly, like x square, okay, when x equal to 2, so 2 square will be equal to 4 and multiply by 2, okay. And then this one, when x is reaching to 2, meaning to say x equal to 2, so 3 multiplied by 2 plus 1, here is a constant limit, it is equal to 1 even x approaches to 2, okay, divided by this. So 2 cube is 8 plus 4. So when you put all these value and calculate, finally we will get some value. So you see, we are applying all the laws of mathematics on the limit of a function, and we can evaluate, we can get some value. Okay, use the limit laws to evaluate this. This one actually I just want to give you like a homework, and you try on this one, and whatever result you get, and please upload the result to eLeap. I will create a link.